Welcome to this explainer. Now to kick things off, I want you to close your eyes for a second and imagine a world where the absolute smallest, most insignificant injury could be lethal. A world where a simple paper cut, a scraped knee, or just a tiny scratch from a rosebush could lead to an unstoppable, agonizing fever. Right? It sounds like science fiction, but this was the terrifying, very real baseline of human existence for thousands of years. Today, we're diving into the cinematic, incredibly suspenseful story of the penicillin miracle. And as you'll see, the real story goes way, way beyond that famous myth of a messy laboratory.
Okay, so what if a simple blister really was a death sentence? To truly wrap our heads around the magnitude of this medical revolution, we have to grasp the absolute desperation of the pre-antibiotic era. Back in the 1920s, a bacterial infection spreading into the bloodstream was, for all intents and purposes, a death sentence. Now, sure, public health experts had actually gotten incredibly good at preventing illness through sanitation and vaccines. But if an infection took hold, even the world's absolute best doctors were entirely powerless. They could clean a wound, but they couldn't stop the bacteria once it was inside you.
And this danger was completely indiscriminate. Just to put this into perspective, in 1924, Calvin Coolidge Jr., the teenage son of the sitting president of the United States, was playing tennis on the White House grounds. He developed a simple blister on his toe. Just a normal blister. But within days, that blister became infected, a massive fever set in, and the infection spread to his blood. Despite being treated by 7 of the nation's leading physicians, the boy died a week later. All the power and privilege in the world literally couldn't cure a bacterial infection.
Section 1. Life before the miracle.
That heartbreaking reality sent scientists into a frantic, desperate search for a cure. We were entering this era of rapid scientific advancement, and the race was on to find a universal treatment that could destroy bacteria without, destroying the patient. By the 1930s, early breakthroughs were starting to pop up. In 1936, another president's son, Franklin Roosevelt Jr., developed a severe, life-threatening sinus infection. He was saved by a new synthetic drug from Germany called Penicillin. At the time, it was hailed as a total miracle. But Penicillin had some severe flaws. It was a synthetic dye that only worked on very specific bacteria. It was completely useless if pus was present, and it was actually mildly toxic. High doses could be fatal, and the side effects included organ damage and, bizarrely, a bluish discoloration of the skin. So it was a stopgap, not the safe, universal cure humanity so desperately needed.
Section 2. The Messy Lab Myth.
And this brings us to the famous story of how that universal cure was supposedly discovered. I mean, if you open almost any school science textbook, you're going to read the legend of an absent-minded genius and a spectacularly lucky accident. The myth goes that in 1928, Scottish bacteriologist Alexander Fleming left his London laboratory a total mess, went on a long summer holiday, and a rare mold magically floated through an open window, landing perfectly on his petri dish to create an instant eureka moment. Well, the reality is far more grounded. It is highly unlikely that rare mold just blew in through an open window. Actually, it was almost certainly carried up accidentally by a colleague working in a lab on the floor right below his. But here's the crucial part. The breakthrough wasn't just the accident itself. It was Fleming's meticulous observation of what that accident actually caused.
Take a look at this. This is Fleming's original Penicillium notatum mold specimen from 1928. What he noticed was this remarkable little halo around the mold, where the deadly Staphylococcus bacteria simply could not grow. The mold was secreting some kind of substance that killed the bacteria, but, and this is key, it appeared non-toxic to human cells. He called it mold juice and later penicillin. But here is the tragic twist of the story. Fleming couldn't stabilize it. The solution was way too impure and its strength just vanished almost immediately. Convinced it could never be turned into a usable drug, Fleming published his findings in a rather dull paper in 1929 and basically gave up.
But let's pause for a second, because as we know, science is a long, continuous chain of observation. Decades before Fleming's famous Petri dish, we have this man, Italian physician Vincenzo Tiberio. Get this, over 30 years prior, in 1895, Tiberio actually conducted controlled studies on the bactericidal effects of mold extracts. He thoroughly documented his findings, but they went largely unnoticed by the broader scientific community. It just goes to show you that the foundation for this miracle was laid by forgotten pioneers long before the history books started paying attention.
Section 3. The Oxford Rescue Mission.
So for a full decade after Fleming's discovery, penicillin just sat there as an obscure laboratory curiosity, until it was rescued from obscurity here, at the Sir William Dunn School of Pathology in Oxford. In the late 1930s, this was a chronically underfunded academic department. but it had recently been taken over by a highly driven 36-year-old Australian pathologist named Howard Florey. Florey was a force of nature. He completely revamped the department, brought in brilliant new minds, secured some absolutely essential funding from the Rockefeller Foundation, and set his team on a mission to systematically study antibacterial substances.
And this is the ensemble cast that actually made the drug a reality. You've got Howard Florey leading the charge, you have Ernst, a brilliant German biochemist who stumbled upon Fleming's old 1929 paper and realized its massive potential, and crucially, you have Norman Heatley. Heatley was the ultimate problem solver. Where Fleming failed, Heatley succeeded. He devised a completely novel method to extract the active substance from the mold, purify it, and stabilize it so it could actually be stored and used as medicine. The guy was so resourceful, he even designed stackable ceramic vessels to grow the mold when standard equipment was totally unavailable because of the war.
By early 1941, the Oxford team finally had enough stable penicillin to try it on humans. This blue plaque marks the Radcliffe Infirmary in Oxford, where on February 12, 1941, the very first human trials took place. And the results? Absolutely spectacular. Patients suffering from horrific, normally fatal infections, people literally on the absolute verge of death from septicemia, began to recover within hours. It was mind-blowing. The Oxford team had proven, for sure, that penicillin worked. But they had a massive new problem on their hands. They could barely produce enough of it to treat a single patient.
Section 4. Scaling up for war.
The timing of all this couldn't have been more critical. World War II was raging across the globe. Millions of soldiers were dying, and not just from bullets, but from battlefield infections, gangrene, and sepsis. The desperate need to mass-produce penicillin shifted from a lofty medical goal to an urgent matter of global security. As we can see, the path to production had this incredibly long gestation period, followed by a sudden, frantic acceleration. British infrastructure was being heavily bombed at the time, so Florey and Heatley flew to the United States in the summer of 1941, basically to beg for help. And they found that help at a U.S. Department of Agriculture laboratory in Peoria, Illinois.
The scientists in Peoria were absolute masters of industrial microbiology. To meet this frantic wartime demand, they completely revolutionized the production process. Step 1. They ditched the slow surface culture method and developed deep tank submerged fermentation, which meant growing the mold in these massive aerated vats. Step 2. They discovered that adding nitrogen-rich agricultural waste, specifically something called corn steep liquor, made the mold grow exponentially faster. And step 3. They literally used X-ray and ultraviolet radiation to mutate the fungus, creating these super strains that produced 1,000 times more penicillin than Fleming's original mold. Just incredible problem solving.
But honestly, perhaps the most amazing twist in this whole shebang comes down to a laboratory technician named Mary Hunt. The team desperately needed a more productive strain of mold than the one Fleming had originally found. So Mary was tasked with scouring local markets for moldy produce. One day, she brings in a moldy cantaloupe she found at a Peoria grocery store. The mold growing on its rind was Penicillium chrysogenum, and it yielded massive, unheard of amounts of penicillin. In fact, that single moldy cantaloupe became the genetic foundation for nearly all industrial penicillin production globally. No way, right?
The result of this unprecedented collaboration between Oxford, the U.S. government, and pharmaceutical companies was just staggering. By mid-1944, just in time for the D-Day invasion of Normandy, they were producing enough penicillin to treat hundreds of thousands of Allied soldiers. Framed as a totally vital war effort, as we can see in posters from the era, penicillin dramatically reduced mortality from wound infections and pneumonia. It completely changed the landscape of the war and of modern medicine forever.
Section 5. Curiosity overcomes blind luck.
With the war won and the world forever changed by antibiotics, a new battle actually emerged. The battle over historical credit. Who actually deserved to be remembered for this medical revolution? Well, in 1945, the Nobel Prize in Medicine was jointly awarded to Alexander Fleming, Howard Florey, and Ernst. The scientific community clearly recognized it was a team effort. But the popular media, they loved a fairy tale. They unfairly elevated Fleming, turning him into this solitary genius who made a lucky discovery through an open window. Meanwhile, the incredibly complex, painstaking chemistry and the massive industrial scaling done by Florey, Heatley, and the teams in Peoria largely faded from public memory.
To his credit, though, Fleming used his newfound massive platform to issue a pretty chilling warning. During his 1945 Nobel lecture, he said, "The ignorant man may easily underdose himself, and by exposing his microbes to non-lethal quantities of the drug, make them resistant. He literally predicted antibiotic resistance the very same year the drug was globally celebrated. It's a remarkably prescient quote that connects this history directly to the critical medical challenges we are facing today.
So what's the ultimate takeaway here? Ultimately, the story of penicillin isn't just about a messy lab or blind luck. Yes, the initial mold contamination was an accident, but scientific breakthroughs don't happen by accident alone. They require intense curiosity, exactly like Fleming's initial observation. And more importantly, they require massive, dedicated collaboration, like the brilliant chemistry of the Oxford team and the industrial might of the scientists over in Peoria. So the next time you hear a simple story about a miraculous discovery, ask yourself, who are the unsung heroes working behind the scenes to turn that lucky spark into a roaring fire?